Good day, everyone. Welcome to EduMath Consult YouTube channel. This is a home where best solutions are preferred to some of the challenging questions. The question on the screen is if bracket open x plus 1 bracket close squared is a factor of f of x equals x cubed plus qx squared plus rx plus 3, where q and r are constants. Find the values of q and r. Number 2, zeros of f of x. This is a question under polynomial, and mostly what you see students do is to expand x plus 1 square and then substitute it in order to get a simultaneous equation. But I must tell you, substituting that x plus 1 raised to power 2 in brackets will not give you different simultaneous equation for which you can use to determine the values of q and r. So in this case, what are we going to do? Now here is the solution. We use the method of comparing coefficients. And before you can do that, then we must be able to guess the third factor of this polynomial, because if you can check this place, you will discover that x cubed is the value, which is a cubic equation. And because it is a cubic equation, that tells us that the factors for this particular equation will be 3. So these are the 2 factors. Then the third factors we guess using letters that are different from this. And so the third factor, I say let the third factor be, I'm going to use ax plus b. Let it be the third factor. Then with that, I will then equate that expression into f of x. That is, my f of x, which is x cubed plus qx squared plus rx plus 3 will be equal to the 2 factors, which is x plus 1 squared, and then the third factor, ax plus b. And then what we need to do is to expand this, then equate it to this as well. So by expanding this, I will be having x squared plus 2x plus 1. You know, x times x gives me x squared. X times 1 gives me 1x, then another 1x, then 1 times 1 will give me. So that is the expansion of x plus 1 raised to power 2. Then you use it to multiply ax plus b. Don't forget, this still maintains itself. Qx squared plus rx plus 3. And then if we expand this further, if you try to expand this further, this is what we are going to get. X squared times ax. I'm going to have ax cubed. Then if you use x squared to multiply b, I'm going to have plus x squared b, or bx squared. Then if you use 2 to multiply this, 2x multiplied by ax, and you are going to have 2ax squared. Then if you use 2x to multiply b, we are going to have plus 2b, 2x times this, 2bx. Then use 1 to multiply this, I'm going to have plus ax, then plus b, which is the constant. Collect the like terms. You can see these are like terms, these are like terms. So if we collect the like terms, I'm having ax cubed plus, you look at it, what can we factorize? The x squared can be factorized. Then inside it, I will have b plus 2a into x squared. Then you consider this, you see x can be factorized. then I'm having 2b plus a into x then plus b. Now don't forget we need to equate it to our original f of x, which is this qx squared plus rx plus 3. This is x cubed plus qx squared plus rx plus 3. Comparing coefficients. If we compare coefficients, that is, this will be compared with this. Now you discover ax cubed is equal to x cubed. Divide both sides by x cubed. If you divide both sides by x cubed, then that is giving us the value of a to be equal to 1. So we've gotten the value of a to be equal to 1. Then compare this x squared with this. Compare it. If you compare, knowing and substituting the value of a in that expression too. So what it means is I'm having qx squared is equal to b plus 2a x squared. Substitute for a and divide both sides by x squared. Divide this side by x squared. Divide this side by x squared. And substituting for a, q is equal to b plus 2 into a is 1. So you can see. So invariably q is equal to b plus 2. And then if you consider just this last digit, look at it. Why I will not be comparing this and this is because I will still be having a repetition of unknown. So compare this b with this. Compare it with this. So what it means is from that expression b equals 3. And so having gotten my a and b, so then I can tell you categorically that this third expression, that is 2b plus a, will be equal to r, or r is equal to 2b plus a. I've known the value of a, I've gotten the value of b. So what is q? So q is equal to b, which is 3. 3 plus 2. My answer is 5. So q is 5. Then to get the value of r is equal to 2b plus a. What is b? 2 into 3 plus 1. That is 6 plus 1. The answer is 7. So therefore, my q is 5 and r is equal to 7. That is answering the first question there. Then the zeros of f of x, that is very easy. That is very easy to get. The zeros of f of x, I will just use this expression. This expression will give me the zeros of f of x. That is x plus 1 squared into ax plus b. You know it will be equated to 0 for us to get the zeros of f of x. So what it means is that I'm having x plus 1 equals 0 twice. Why am I writing twice? This is square. Then x is equal to minus 1 twice. Then the second one, a, what is a? Our a value is 1. So you substitute 1x plus what is my b value? That is 3 equals 0. So meaning x plus 3 equals 0 and x equals minus 3. So therefore, the zeros of our f of x, the zeros of f of x are minus 1, and minus 3, which satisfy the solution to a cubic polynomial, a cubic expression. Thank you.